For this next one, we're going to look at limits involving infinity, and specifically we're going to look at these limits that are rational functions, a polynomial on the top and a polynomial on the bottom. And they have a very nice trick, a very nice rule that says we can learn a lot about these limits just by looking at the degree, the highest power of the exponent on the numerator and the denominator. For example, in this one, the highest power is 2, so the degree at the top is 2, and the highest power here is 2 as well, so the degree on the denominator is 2. So this limit actually ends up equaling the limit as x approaches infinity of 4x squared over 3x squared. Now, it turns out that when you're having x approaching infinity, it's always the case that these other non-leading terms, these smaller powers of x, don't end up mattering. So in this case, since the degrees are both 2, these x squareds will cancel out, and the answer is just 4/3. And in fact, you don't even hardly need this much. If you have any polynomial where the degrees are the same, like this next one, any rational function where the degree on the top is the same as the degree on the bottom, here the degree is 4 and there the degree is 4, then you just look at their leading terms. Here the leading term is -7, and here the leading term is 11, and the answer is -7/11. So these end up being a really easy way to deal with those. Now what happens when the degrees are different? Here the degree on the bottom is bigger. I could still get rid of all the non-leading terms and say that this is the same as the limit as x approaches infinity of x over 3x squared. These x's would cancel out, and I'd have a 1 on the top over 3x, and as x gets enormous, this goes to 0. And in fact, whenever the degree on the bottom is bigger than the degree on the top, like for instance here, the degree is 6, here the degree is 5, I know this answer is going to be 0. The third case is what happens if the degree on the top is bigger? Well, like here, the degree is 2 up here and the degree is 1 here. Well, I can again, this trick only works as x is approaching plus or minus infinity. I can again ignore all the non-leading terms and say this is 4x squared over 4x. Lots of stuff cancels out here. The 4's cancel out. This x cancels out with one of those x's. And I have the limit as x approaches infinity of just x, which is infinity. In fact, if the degree on the top is higher than the degree on the bottom, the limit's always going to go to plus or minus infinity. And you can simplify to figure that out. So I know that this answer, for instance, is either going to be plus infinity or minus infinity. So I'll go ahead and put the infinity there. And I need to know whether it's a plus or a minus. Well, if I plug in a very big positive number, this bottom number is positive. This top number is going to be a negative something squared. So that's going to be a very big negative number. And a negative number over a positive number is negative. So this is going to end up being negative infinity. So these type of limits of rational or rational-like functions as x approaches plus or minus infinity should be pretty quick.